Did you know that the world uses over 160,000 terawatt hours of energy per year, and a whopping 67% of it is wasted? Yes, let that sink in for a moment. Our planet, with all its technological advancements, still squanders nearly two-thirds of the energy it consumes. It's like cooking a three-course meal only to throw two-thirds of it in the bin. Shocking, isn't it? This staggering amount of energy waste is primarily due to the inefficiencies of our current energy grid systems. These systems were designed and built in a time when energy usage was much lower and far less complex. Today, our energy demands have grown exponentially, and the variety of energy sources has expanded dramatically. Yet, we're still relying on outdated infrastructure that is ill-equipped to handle the modern energy landscape. Our current grid systems are like a one-way street. They distribute energy from power plants to homes and businesses, but they don't allow for feedback. So, when there's an unexpected surge in demand or a power source fails, the system can't adapt quickly enough, leading to power outages and wasted energy. But the problem isn't just about wasted energy. It's also about the environmental impact. Wasting 67% of our energy means we're unnecessarily increasing our carbon footprint, contributing to climate change, and depleting our planet's natural resources at an unsustainable rate. It's clear that our current approach to energy consumption is unsustainable and needs a radical overhaul. We need a system that is more efficient, more resilient, and more adaptive. A system that can handle the complex, ever-changing demands of the 21st century. If you're as startled by these numbers as we are, stick around to learn about a solution that could revolutionize energy consumption. This is not just about saving money on our energy bills. It's about building a sustainable future for our planet, for our children, and for generations to come. So, are you ready to be part of the solution? Energy networks, often called grids, are not as simple as they seem. They're intricate systems built over decades, sometimes centuries, and their complexities can be mind-boggling. It's like a colossal, never-ending ballet where every dancer has a critical role to play. Let's start at the beginning. Energy production. Whether it's a coal-fired plant, a nuclear reactor, or a hydroelectric dam, energy is generated at a large scale. But these forms of energy production are not without their drawbacks. They're often located far from the places where energy is most needed, leading to transmission losses. Furthermore, they are reliant on finite resources, which poses a sustainability issue. Then comes the transmission stage, the process of getting this energy from the source to your homes and businesses. This is done through high-voltage power lines that stretch across hundreds, sometimes thousands of miles. However, these lines aren't perfect conductors. As the energy travels, a portion is lost as heat due to resistance. It's like trying to squeeze a full-sized marshmallow through a tiny straw. You're bound to lose some in the process. Next, we have the distribution stage, where energy is finally delivered to end users. This involves stepping down the voltage from transmission levels to something that won't fry your toaster. But here's the catch. The grid has to be prepared for peak demand, even if that peak only happens for a few hours each year. It's like building a 10-lane highway just for the 5 o'clock rush hour. All these stages, from production to distribution, have inherent inefficiencies. These inefficiencies, in turn, lead to higher costs, wasted resources, and increased environmental impact. It's like we're trying to navigate a complex maze, but we're losing breadcrumbs along the way. The inefficiencies of these traditional grids are costing us dearly. But what if there was a smarter way? What if we could build a system that is not only more efficient, but also more resilient, more flexible, and more sustainable? That's the promise of smart grids, and in the next scene, we'll dive deeper into this fascinating topic. So, stay tuned. Enter the world of smart grids, the next generation of energy networks. Imagine this: a world where energy flows both ways, where your power company knows the moment your lights flicker, and where your home appliances can automatically adjust their energy usage to save you money. This isn't a science fiction dream, it's the reality of smart grids. Smart grids are a revolutionary upgrade to our existing energy networks. They're not just about delivering electricity from power plants to homes or businesses. They're about creating a two-way street for energy and information. This two-way communication allows for real-time data collection and automated responses, making our energy usage more efficient, reliable, and sustainable. But what does this really mean? Let's break it down. Two-way communication is a game changer. Traditionally, energy was a one-way street. It flowed from the power plant to your home. But with smart grids, energy and information can flow both ways. This means your power company can detect and fix issues in real time, and you can even sell excess energy back to the grid if you're generating your own power with solar panels or wind turbines. The real-time data feature is like having a pulse on the entire energy network. It allows for immediate response to changes in energy demand or supply. So, if everyone turns on their air conditioning at the same time on a hot day, the grid can adjust accordingly to prevent blackouts. Automated responses take this one step further. Smart appliances in your home can communicate with the smart grid, adjusting their energy usage based on grid conditions. This could mean your dishwasher waits to run until off-peak hours when energy is cheaper, saving you money and reducing strain on the grid. These are just a few features of smart grids. They're not just about more efficient energy usage. They're about creating a more resilient and adaptable energy network, one that can handle the demands of the 21st century and beyond. Smart grids are set to transform the energy landscape, but how exactly do they work? Smart grids, despite their complexities, operate on a simple principle: efficiency. They are like the brain of the power network, constantly processing information and making decisions to optimize energy use. But how exactly do they do this? Let's dive in. The magic begins with smart meters. These devices are the eyes and ears of the smart grid, monitoring the energy consumption of individual homes and businesses. They're a bit like your regular utility meters, but with an upgrade. They not only measure how much energy you're using, but also when and how you're using it. This allows the grid to adjust the supply based on the demand, preventing overloads and blackouts, and ensuring you always have power when you need it. But smart meters are just one part of the puzzle. There are also phasor measurement units, which keep an eye on the health of the grid. They measure voltage, current, and frequency at various points along the grid, allowing operators to spot potential problems and fix them before they cause power outages. Then there's the communications network, the nervous system of the smart grid. This network connects all the components of the grid, allowing them to talk to each other and share data in real time. This constant communication is what makes the grid smart. It's like a group of friends on a group chat, always updating each other about their status and plans. Now, with all this data flowing in, how does the grid make sense of it all? That's where automation comes in. Sophisticated software algorithms analyze the data, identify patterns, and make predictions. For example, if the data shows that everyone starts using more power at 6 in the evening, the grid can anticipate this and adjust the supply accordingly. This real-time data and automation together play a huge role in reducing energy wastage. By matching supply with demand, the grid ensures that no energy is wasted. It's like having a personal assistant who always knows exactly how much energy you need and when you need it. Moreover, the smart grid also supports renewable energy sources, like wind and solar power. It can manage the variability of these sources, storing excess energy when the sun is shining or the wind is blowing, and releasing it when it's needed. In essence, the smart grid is a dynamic, responsive system that adapts to our energy needs. It takes the guesswork out of energy management, making it more efficient, more reliable, and more sustainable. So, we've seen how smart grids work and how they contribute to energy efficiency. We've talked about smart meters, phase or measurement units, the communications network, real-time data, and automation. But we've only just scratched the surface of this fascinating technology. By now, you might be wondering, what does this mean for us, the consumers? Smart grids are not just about saving energy, they're about saving money and the environment too. Imagine this. You're sitting at home, perhaps enjoying a nice cup of coffee, when suddenly your energy provider sends you a notification. Your energy consumption has spiked, and you're able to address it immediately, preventing an unexpectedly high bill at the end of the month. Sounds like a dream, right? Well, that's the reality with smart grids. They empower you, the consumer, with real-time data about your energy use, helping you manage your consumption more effectively. But it's not just about saving money. Smart grids also increase the reliability of your energy supply. Traditional energy networks are susceptible to power outages and blackouts, often leaving you in the dark, quite literally. On the other hand, smart grids are designed to be resilient. They can detect and isolate faults quickly, minimizing disruptions to your power supply. Imagine a future where power outages are a thing of the past. That's the promise of smart grids. And let's not forget about the environmental benefits. As we transition to a more sustainable future, renewable energy sources like solar and wind power are becoming increasingly important. However, integrating these sources into traditional energy networks can be challenging. But here's where smart grids shine. They can accommodate a diverse range of energy sources, making it easier to harness renewable energy and reduce our carbon footprint. Smart grids also enable energy efficiency at a larger scale. By optimizing the flow of electricity, they reduce energy loss during transmission and distribution. This not only conserves energy, but also reduces greenhouse gas emissions. So, by embracing smart grids, we're not just saving on our energy bills, we're also playing a part in protecting our planet. And there you have it. The potential benefits of smart grids for consumers like you and me. They promise reduced energy bills, increased reliability, and a significant contribution to environmental sustainability. So, are smart grids the definitive answer to our energy woes? Like any revolutionary technology, smart grids come with their own set of challenges. The journey towards a more energy-efficient world through the implementation of smart grids is not without its hurdles. One of the biggest obstacles is the sheer cost of the initial investment. The transformation of traditional power grids into smart grids involves substantial expenses. These costs cover the installation of smart meters, the development of communication networks, and the creation of advanced software for data analysis. But despite the high upfront costs, the return on investment can be substantial. Think of it this way. It's like installing solar panels on your roof. Yes, there's a significant initial cost, but over time, the savings on energy bills can more than make up for it. Another major challenge is privacy. With smart grids, energy consumption data is collected in real time. This could potentially give rise to privacy concerns, as it might reveal sensitive information about consumers' daily routines. However, this concern can be mitigated with robust data encryption and strict privacy laws. Regulatory changes also pose a significant obstacle. Current regulations are designed for traditional power grids. To make way for smart grids, we need new regulations that accommodate the unique features and capabilities of this technology. This involves revising tariff structures, setting new standards for grid interconnections, and creating policies that encourage the adoption of smart grids. Now, let's talk about solutions. How do we overcome these challenges? For the high upfront costs, we can leverage public-private partnerships. Governments can subsidize the initial costs to incentivize private companies to invest in smart grid technology. Alternatively, utility companies can introduce dynamic pricing, where electricity prices vary based on demand. This can encourage consumers to use electricity during off-peak hours, leading to more efficient use of energy and lower costs in the long run. To address privacy concerns, we need to design smart grids with security in mind. This means using advanced encryption techniques to protect data and implementing strict privacy policies. Consumers should also be educated on how their data is used and how they can protect their privacy. As for regulatory changes, policymakers need to work closely with energy experts to develop regulations that accommodate smart grids. This could involve creating incentives for utilities to invest in smart grid technology, revising tariff structures to reflect the true cost of electricity, and setting standards for grid interconnections that ensure the reliability and security of the grid. Looking ahead, the future of smart grids is promising. With the advent of renewable energy sources and electric vehicles, the demand for smart grids is set to increase. Smart grids can integrate these technologies seamlessly, paving the way for a more sustainable and energy-efficient future. Moreover, as artificial intelligence and machine learning continue to advance, they can be incorporated into smart grids to analyze energy consumption data and make real-time adjustments to improve efficiency. Imagine a grid that learns from its past performance and continuously optimizes itself to deliver the most efficient energy distribution. That's the future we are looking at with smart grids. In conclusion, while the road to smart grids is fraught with challenges, the potential benefits are immense. Overcoming these challenges requires a concerted effort from governments, private companies, and consumers. But the reward is a more sustainable, efficient, and flexible energy system that benefits us all. Smart grids have the potential to redefine our energy future, but it's up to us to embrace this change and make it a reality.